I'm going to be talking about cholesterol synthesis, bile synthesis, and steroid hormone synthesis in this video. These three pathways, they occur in different places. So let's start with cholesterol synthesis. This is happening in the liver. We're starting with acetyl-CoA and we're ending with cholesterol. So thiolase turns acetyl-CoA into acetyl-acetyl-CoA. HMG-CoA synthase is turning acetyl-acetyl-CoA into HMG-CoA. So these few steps are the same as ketogenesis, except here's where it changes. So the rate-limiting enzyme of cholesterol synthesis is HMG-CoA reductase. It's turning HMG-CoA into mevalonate. Mevalonate is a 6-carbon molecule. Mevalоnate's turning into isoprene units, which are 5-carbon molecules, but we are using 6 of them, putting them together, and making squalene, which is a 30, because 5 times 6 is 30, so it's a 30-carbon molecule. Squalene is undergoing a cyclization reaction where it's just moving. It's essentially the same molecule, just in a different structure. So linosterol also has 30 carbons too. It's removing 3 carbons to become the 27-carbon molecule known as cholesterol. So, like I said, these first few steps are part of ketogenesis, and then I remember my skin loves cholesterol. I think about that because cholesterol helps you make vitamin D, and squalene is in skincare that I use, so that's what I think of. Cholesterol is also the starting reactant in bile synthesis as well as steroid hormone synthesis, so those are the precursors, or cholesterol is a precursor for these 3 things. And moving over to cholesterol being turned into bile. So that still happens in the liver. So bile is made in the liver, but stored in the gallbladder and released into the small intestine when we eat lipids. So we start with cholesterol. Cholesterol turns into 7-alpha cholesterol. 7-alpha hydroxylase turns 7-alpha cholesterol into 7-alpha hydroxycholesterol. 7-alpha hydroxycholesterol turns into the 2 bile salts, cholic acid and CDC acid, or chenodeoxycholic acid. Steroid hormone synthesis occurs in the gonads and the adrenals, starting off with cholesterol. Desmolase is the rate-limiting enzyme of steroid hormone synthesis. It's turning cholesterol into pregnenolone. Pregnenolone turns into progesterone. Then progesterone makes DHEA, cortisol, and aldosterone. Cortisol and aldosterone are known as corticosteroids. DHEA is the strongest, most potent form of testosterone, and testosterone turns into estradiol. So these are sex steroid hormones. Cholesterol synthesis is stimulated by insulin because it's a synthesis pathway, and insulin stimulates synthesis pathways. Acetyl-CoA stimulates this pathway because that's what we need to start the pathway. This is a little more confusing. Dephosphorylation. So just remember that insulin and dephosphorylation go together, and glucagon and phosphorylation go together. So if insulin stimulated, so is dephosphorylation. Inhibitors of cholesterol synthesis are glucagon and phosphorylation, because cholesterol synthesis is a fed state pathway. So glucagon and phosphorylation, those are fasting and starvation state hormones, so that won't be high right now. Glucocorticoids or corticosteroids. So if these are high, this means we don't need to be synthesizing cholesterol since we already have the products. If we have high bile acids, that means we don't need to do cholesterol synthesis because we already have some. Mevalonate inhibits cholesterol synthesis, because if this is high, this means that we don't need to do the reaction. Obviously, cholesterol will inhibit cholesterol synthesis because this is what we're trying to make. If we have it, we don't need to make more. And statin drugs inhibit HMG-CoA reductase to lower cholesterol. Cholesterol is made in our liver, so it's made endogenously in the liver and in the small intestine, but we also get it from food that we eat. I hope that made sense.